Okay guys, can you see everything okay on here? Can you hear me everything okay? So that I can get started. Just type in the chat box please. Can you hear me now, Fatima? I haven't really been saying much. I've just been playing around on the computer. Hello? Testing 1 2 3. Why do I do this on a Monday morning? Okay, good. Fatima, can you hear me yet or what? Fatima's probably a bit distracted. Right, okay. So, last time when we were looking at variable acceleration, let's just have a look at this. Right, okay, good, Fatima. Last time when we were looking at this, we found that the gradient, if I had displacement, so some formula S is equal to f of t. If I differentiated that, if I dt f of t, I would get the velocity. That would give me velocity. And if I now differentiated that again, so if for example I did d2 over dt squared of f of t, I would get acceleration. Okay, that's what I would get. So that then implies that if I wanted to go back up from acceleration to velocity, going down I'm having to differentiate. What if I wanted to get from acceleration to velocity? Well, it's the opposite of what we're doing here, and the opposite therefore would be to integrate, and that is where this chart comes in. So going from S to V I'm differentiating, going from V to acceleration I'm differentiating. If I wanted to go from A to V I'd integrate, and then if I wanted to go from V to S again I would integrate again. So let's have a look at this question here. It says a particle is moving on the x-axis. At time t the particle is at the point where x equals 5. So it's giving you some information. The velocity of the particle at time t seconds is 6t minus t squared meters per second. Find an expression for the displacement, and then the distance the particle is from its starting point when t equals 6. Right, okay. So what we've been given here is a formula for velocity. So I'm going to just get this down on here. So we've been told that the formula for velocity is equal to 6t minus t squared, and I've also been told that at t equals 0, x equals 5. At t equals 0, x equals 5. That's what was told to us over here. X, don't forget, is displacement. So now over here I need to work out what the question that I've been asked to work out is. What is displacement? The formula for x equals question mark. To get from velocity to acceleration, I'm going to have from velocity to displacement, I'm going to have to integrate. So I'm going to write x is equal to the integral of 6t minus t squared dt, and upon integrating this, I'm going to add 1 to the power, divide by the new power, so 3t squared minus t cubed over 3 plus c. So that is what x is equal to. Now, we have been told at this stage that when time equals 0, the displacement is equal to 5. This will enable us to work out what my constant is. And this is a key part. You need to understand from the question what these are called initial boundary conditions here. This, this bit here is known as your initial boundary conditions, and you need them to work out any constants that you have. Now, I'm going to substitute them in and work out what c is. So at time t equals 0, x equals 5, so 5 equals, this is going to become 0 minus 0 plus c. So at my initial value, my displacement is 5. Right, okay. Now I've got the full formula for x. X is equal to 3t squared minus t cubed over 3 plus 5. That's what I have so far on here. Now, using this formula, I can answer any questions about displacement at any time. So, an expression for the displacement from O at time t seconds, we've done that in part A. For part B, it says the distance of the particle from its starting point when t equals 6. When t equals 6. So, I need to substitute, essentially saying what is the displacement of the particle from its starting point when t equals 6. So here, all I need to do is say, well, x is equal to 3 times by 6 squared minus 6 to the power of 3 over 3 plus 5, and that will give me, so 6 squared is, I don't know what that is, 36 times 3 is 108 minus 216 over 3 plus 5, so 108 minus 72 plus 5, that is equal to, oh, this is so slow, 41 meters, and there's your answer. Okay, so let's just check this. And alright, from its starting point, so yeah, so if you just look at this, when t equals 6, the distance is 41, but initially it was already 5 meters from its starting point already, so it's going to be 41 minus 5, which is equal to 36 meters, because it told us that from the starting point it was already 5 meters away from where it started off, and therefore it needs to be 41 from the 5 meters that we've already got in there. Right, okay. Any questions? I'm going to move on. Right, okay. So particle travels in a straight line. After t seconds, its velocity is v meters per second. It's given by some formula there. Find the distance travelled by the particle in the 3rd second of its motion. So again, we've been given velocity here, and we need to find the distance travelled. Okay, so we need to go from velocity to displacement. How are we going to do that? To go from velocity to displacement, I'm going to need to integrate. So first I'm going to write down the formula for v. V is equal to 5 minus 3t squared, and particle travels after t seconds is given by that. So looking at this question here, what are the boundary conditions? Can you type into the chat box what you think the boundary conditions are, because it's not apparent what the boundary conditions are here at this point in time. So have a go at typing into the chat box here and what you think the boundary conditions are. I'm here, Fatima. So t equals 3. No, that's not the boundary conditions, because let me explain to you what I mean by boundary conditions, because it's not clear. Right, so over here let's integrate, because we know I need to work out x. So to work out x, the displacement, I'm going to have to integrate v. So here we go, I'm going to integrate v. X is equal to the integral of this dt. And when I integrate that, I'm going to get 5t minus 3t cubed over 3 plus c. And if I simplify this, I get 5t minus t cubed plus c. Now, how am I going to work out what c is? I need to work out what this constant is, because without that I won't get an accurate answer for the displacement. In order for me to work out what c is, I need boundary conditions. I need what velocity any displacement is. Sorry, I need some sort of conditions. T equals something and x equals something. Right, over here, particle travels in a straight line. After t seconds, its velocity is given by that much. find the distance t is greater than or equal to 0. Now over here it doesn't tell us any boundary conditions, these were not given. Okay, but we have to assume that by travelling in a straight line at time t equals 0, it's not travelled any distance because it hasn't told us that so far. So when t equals 0, x equals 0. So over there we get that 0 is equal to 5 times by 0 minus 0 cubed plus c, so therefore c is also equal to 0. Now that I've got my formula for displacement, x equals 5t minus t cubed, I can work out how much the particle travels in its third second. Find the distance travelled by the particle in the third second of its motion. Now, in its third second, it's not saying what is the displacement at time t equals 3, it's asking us to find out the distance travelled in the third second. In that 1 second, what was the distance travelled? So, for me to work that out, I would need x at time equals 2, x at time equals 3, and the difference between them will be the distance travelled in the third second. So I'd like you to work that out and tell me what the answer is in a second, please. Guys, you worked it out, yeah? Yep, Amir, is right. Okay, so over here, when you substitute in t equals 2 and t equals 3, you get you're gonna get 14. So let's see how else we could have done it. So another way to think about this is I've been given the velocity formula here. Okay, and I need to work out the distance travelled. Now the distance travelled is the integral, or the area underneath the velocity time graph. So here, instead of doing this and working out what c is and having to worry about what c is, I've also just thought about this, is that the distance travelled is equal to area under velocity time graph. So over here what I would have had is v is equal to 5 minus 3t squared and just give me a second. I would have got that the velocity, the distance traveled is the integral or the area underneath the velocity time graph. So distance in the third second is going to be equal to the integral from 3 to 2, because that will give you the distance traveled only in the third second of 5 minus 3t squared dt. So working with this, I've already worked out the integral 5t minus t cubed between the limits of 3 and 2. Now when I substitute those values in there, I get 15 minus 27 take away 10 minus 8, which then gives me minus 14. Right, but we just want the area underneath the velocity time graph. We are not concerned with whether it's positive or negative, because we want the distance traveled, and therefore the distance traveled is going to be 14 meters in the third second. Okay, are there any questions about this? Right, okay, I'm gonna move on. So looking at this, right, yeah, so you didn't even have to work out the boundary conditions there. That was a mistake on my part. You could initially just do it straight from a definite integral, and therefore you didn't have to worry about what c is. Right, I'm gonna move on now. Right, let's have a look at this. Let me just move this chat thing away. Right, so you've got a particle here. P moves on the positive x-axis. Velocity of P is given by some formula. When t equals 0, P is 15 meters from its origin. So they're the boundary conditions, and then we need to find out a number of things off the back of that. Okay, so for part A, we want the values of t when p is instantaneously at rest. I'm just going to go over to my blackboard and write this formula down. So 2t squared minus 9t plus 4. So v is equal to 2t squared minus 9t plus 4. It tells us that x is equal to 15, because 15 meters from the origin, when t equals 0. It tells us that. These are known as the boundary conditions. These are boundary conditions, and we want, for part A, when is P at rest? So when is P at rest? Instantaneously at rest. Well, that is when V is going to be equal to 0. And when is v equal to 0? Well, that implies that 2t squared minus 9t plus 4 is equal to 0. And factorizing this, I'm going to get 2t squared minus 8t minus t plus 4 equals 0. 2t t minus 4 minus 1 t minus 4 2t minus 1 t minus 4 is equal to 0. And solving that, I get t is equal to a half and t is equal to 4. So my velocity time graph looks something like, there's a half, there's 4, it's a quadratic. At time t equals 0, at time t equals 0, the velocity is equal to 4. So if I just label my axes v and this is t, it looks something like that, and this is 4 here. Because when t equals 0, if I substitute t equals 0 into this expression here, I'm going to get that velocity is equal to 4. So I'll get a quadratic that looks like that. Okay, this might be useful later on. It's just good for your understanding. Right, now part B, let's go over. So let's just have a look at this. Right, so that's good. Now part B, the acceleration of p when t equals 5. So for part B, the acceleration of p when t equals 5. So if I just go down and extend my page. So for part B, we need to find out acceleration equals question mark and t equals 5. How are we going to get from the velocity graph to the acceleration graph here? How are we going to get from velocity to acceleration? Please answer in the chat box. Yeah, that's brilliant. So I need to differentiate, and I know that velocity is equal to 2t squared minus 9t minus 9t plus 4. So if I differentiate that, acceleration is going to be d dt of this expression, 2t squared minus 9t plus 4. And from there I get that acceleration is equal to 4t minus 9. That is my formula for acceleration, and I need to work out the acceleration at the instant where t equals 5. So a is going to be equal to 4 times by 5 minus 9, which is 11 meters per second squared. Okay, and that helps us answer part B. Now part C, the total distance travelled by p in the interval of t equals 0 to 5. So we need to work out the total distance travelled between t equals 0 and t equals 5. So for part C, distance travelled between t equals 0 and t equals 5. Well, distance travelled, we know from today's learning, is the area underneath the velocity time graph. Now between t equals 0 and t equals 5. So coming back to this graph, I need to work out the area between 0 and 5. So if I just use different colors so that I can shade in, over here, I've got this positive area and I'm going to have this positive area, and then I'm also going to have a negative area here. Now if I integrated straight away between t equals 0 and t equals 5, I would have had some of the positive cancel out with some of the negatives, and I would have done it incorrectly. I wouldn't have worked out the total distance travelled. What I have to realise is, because there are some parts of this curve above the x-axis and some part below, I need to do it in individual bits. So if I call this bit here part 1, call this here part 2, and call this bit here part 3, I'm going to find a general expression for the integral, and then use different sets of 3 sets of limits to help me work out what the total distance travelled between 0 and 5 was. So let's have a look at this. So the distance is going to be because it's a definite integral, I don't need to worry about the constant. So it's going to be the integral of 2t squared minus 9t plus 4 dt. And like I said, because it's a definite integral, I don't need to worry about what the constant is. So here I'm just going to get an expression 2 over 3 t cubed minus 9 over 2 t squared plus 4t. That is my expression for the definite integral. Now I need to work out all the individual areas, the 3 individual areas, separately. So distance travelled in part 1, distance in part 1 from the graph, if you think about the graph, would have been the integral from 0.5, because the first point where the graph crossed the x-axis was at 0.5, and it started the origin of, I'm going to write that 0 more clearly, of v dt. So therefore that then becomes 2 over 3 t cubed minus 9 over 2 t squared plus 4t between the limits of 0.5 and 0. Then in part 2, we're going to get the integral of the same thing between the lower limit now becomes 0.5 and the upper limit becomes 4. And finally, in part 3, well, firstly we need to understand this area is going to be negative. Area will be negative. Now if it's negative, I need to turn it positive. Therefore I need to turn it positive. Distance is positive, so therefore distance needs to be positive, so therefore I need to convert it from negative to positive. And then again in part 3, it's going to be the same integral between 5 and 4, because the upper limit was between, upper limit of the distance travelled was 5, and this is the last part of the curve. So I want you to work all of these separate bits out and tell me your final answer at the end. Come on, Fatima, I hope you're not distracted by everything else on your desktop or whatever it is that you're watching this on. Right, what answer did you guys get? So for the first part, I think, right, let's check the answer, man. Uh, 233 over 12 is giving us 19 point something there has gone wrong. Right, so why has that happened? So yeah, these are the correct integrals the limits. Now you can see that they've turned the negative part positive by putting a minus in front. Look at the values there and see why that has gone wrong, Amir. So for the first integral you get substituting 0 and you get 0, substituting a half and you get 23/4, substituting alright, so the area of the second bit there is going to be minus 40/3, but adding that on will change it. Yeah, hopefully this makes sense here. And then you figured out what went wrong in here, looking at the mark scheme. Yeah, no, but plus 15 will cancel out. The plus 15 will cancel out for each bit, because when you substitute in a half, you're going to have plus 15. When you substitute in 0, you're going to have minus 15. So the plus 15 bit's going to cancel out for each one of those. You don't need the constant. So that shouldn't have made any difference. Right, I'm going to work with you on this so that I'll make sure everything is correct. Right, okay. So for this integral here, you get 23/24. So the distance travelled between 0 and 0.5 seconds is 23/24. When I substitute 4 and 0.5 into the expression, I get, right, give me a second. When I substitute in 4 into this expression, I'm going to get equals minus 40/3 take away 23/24. So I get an area which is going to be minus 40/3 minus 23/24, and that gives me minus 43/3. Now this is a negative area on the graph, but the distance travelled can't be negative, so therefore I need to turn this positive, and this therefore will end up becoming 43/3, positive 43/3. And then finally for this, when I substitute, oh, I see what's going on. Okay, right, now that you understand that, that's cool. And then you get the right answer. Yeah, maybe that's something to bear in mind. I've already integrated the expression. All I needed to do was substitute values in there. So it'll probably be easier for you to do that integral step and substitute values in all at the same time. Right, okay. I'm going to call that a lesson. I'm going to do another session on Thursday morning, I'll send out another email. Again, guys, I need your feedback. Amir, you need to answer the questions, the 2 questions I asked you. What did you find useful about these sessions? What do you think can be improved, or what don't you like about it? Positive or negative. I need this feedback to help me structure the next lesson. Alright guys, thank you for tuning in. I'll see you back on Thursday. Thanks.